Hello, teacher. Hello, students. Welcome to today's lesson about the theorems on polynomials. In the last lesson, we learned the definition of a polynomial, its elements, and its four basic operations. Today, we will learn about three theorems of polynomials: the division theorem, the remainder theorem, and the factor theorem. Are you ready, students? Let us begin with the division theorem. The polynomial division theorem is defined as the following: f of x and d of x are polynomials such that d of x does not equal 0, and the degree of d of x is less than or equal to the degree of f of x. In this case, there are unique polynomials called q of x and r of x, such that f of x equals d of x times q of x plus r of x. R of x equals 0, or the degree of r of x is less than the degree of d of x. If the remainder r of x is 0, f of x divides exactly into d of x. This theorem sounds complicated, students, but is actually simple to apply. Let us test it with an example. Here is a polynomial. Let us find the unique polynomial functions q of x and r of x. We must divide f of x into d of x. Therefore, let us divide x squared minus x plus 7 into x plus 1. We can use long division to factor the equation. The dividend is equal to x minus 2 with a remainder of 9. Do you remember how to express remainders, students? The remainder 9 is the numerator of a fraction. The polynomial's divisor, x plus 1, is the denominator of the fraction. F of x divided by d of x is equal to x minus 2 plus 9 over x plus 1. So x squared minus x plus 7 is the product of x plus 1 multiplied by x minus 2 plus 9. We have found our answer, students. Q of x equals x minus 2. R of x equals 9. This is how we can apply the polynomial division theorem to solve problems. Now, let us study the remainder theorem. The remainder theorem of polynomials states that when f of x is divided by x minus a constant, the remainder is always a constant. Let f of x be a polynomial of degree greater than or equal to 1, and let c be any real number. if f of x is divided by the linear polynomial x minus c, then the remainder is f of c. Let us apply this principle to our last example. If you remember, f of x was x squared minus x plus 7. D of x was x plus 1. The polynomial division theorem states that f of x divided by d of x is equal to x minus 2 plus 9 over x plus 1. The remainder theorem holds that if x equals -1, the result will be equal to the remainder 9. Simple substitution will allow us to test this idea. The theorem is correct. The result of substituting -1 for x is equal to 9. It is time for an activity, students. Here is a polynomial. First, use the polynomial division theorem to find the value of q of x and r of x. Then, use the remainder theorem to verify your answer. You may get started right away.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. You have 2 new theorems to apply. Let us see how well you did. Using the polynomial division theorem, we find the value of q of x to be 2x plus 1. We also find r of x to be 0, as the remainder is 0. Using the remainder theorem, we find the remainder to be 0, which verifies our result found by using the polynomial division theorem. Great work, everyone! You are showing an admirable grasp of both the division theorem and the remainder theorem. We have one more theorem left to learn. It is called the factor theorem. You will recall that factorizing a polynomial means to writing as the product of 2 or more other polynomials. Let f of x be a polynomial of degree greater than or equal to 1, and let c be any real number. In that case, x minus c is a factor of f of x if f of c equals 0. Conversely, f of c equals 0 if x minus c is a factor of f of x. Try applying this theorem for yourself, students. Look at these 3 polynomials. Use the factor theorem to determine whether or not g of x is a factor of f of x.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. F of negative 1 is equal to 0. X plus 1 is a factor of f of x. F of 1 is equal to 1, not 0. X minus 1 is not a factor of f of x. F of 3 over 2 equals 14, not 0. So x minus 3 over 2 is not a factor of f of x. If those were your answers, great work. That is all for today. We have learned about the division, remainder, and factor theorems. Until next lesson, thank you, teacher. Thank you, students.